So laws of exponents talked about in Algebra 1. And I've got your 6 properties, your 6 laws right here. So remember, just a quick review of these, right? When you multiply the same base, right, the important stuff out of here, multiplying the same base, you add the exponents, right? When you are dividing the same base, you subtract your exponents. Anything to the 0 power is 1, except 0. That's undefined, but we'll get into that later. And then if you have a power raised to another power, you multiply the exponents. And if you have a product or a quotient raised to a power, so if you got stuff in parentheses being raised to a power, then everything in those parentheses needs to be raised to that power, okay? And then negative exponents, that doesn't make the base negative, it just changes the position of the base within a fraction. So like in this first one right here, a to the negative n, right? That's in the numerator of a fraction. So to make that exponent positive, we take this thing and we shift it to the denominator to make it 1 over a to the positive n. And then likewise, if it's 1 over a to the negative n, to make that exponent positive, we shift it up to that numerator and it becomes a to the positive n. So negative exponent just tells you to move it in the fraction, okay, to make it positive.
Okay, number 16. So we have a power to a power. So in this case, I need to multiply these two exponents. So I have t to the 2 times 5, which is t to the 10th power. Number 17. So again, we have a power to a power. So I have z to the negative 3 times 6, and negative 3 times 6 is negative 18. So it's z raised to the negative 18th power. But remember, since we have a negative exponent, we need to remove those exponents to make this simplified. So since we have a negative exponent, let's put it all over 1. We're going to move this to the other side. So we have z, and now it's going to be raised to positive 18. Okay, so that negative, when you move it to the other side, the negative goes away. So it's going to be z to the 18th power. But what's going to be up top? Well, it's just going to be 1. So that's your answer. Number 18. So if we have a power of a product or quotient, so in this case, we're looking at this thing. We can distribute the negative 1, so it looks like this. We have r to the 4th power times negative 1, right? And then s to the negative 3rd power times negative 1. So this is going to be r to the negative 4th, and this is going to be s to the positive 3. We can't have negative exponents, so what I'm going to do is I'm going to put it all over 1. And this r to the negative 4th power is just going to move to the other side. So now we have r to the 4th power. Again, when you move a number that has a negative exponent, you move it to the other side, and now that exponent is going to become positive. What about that s to the 3rd? Well, nothing is going to happen to that variable. In fact, we're just going to leave that in the numerator. So our answer is s to the 3rd over r to the 4th. Okay, number 19. So we have, again, a power of a product. We're going to distribute the exponent of negative 2 to each of those bases. So we have 2 to the negative second power. We have x to the negative 11 times negative 2. Y to the negative 11 times negative 2. And then z to the 11th power times negative 2. Okay? So, I'm not going to worry about 2 to the negative second power yet, but I can look at that x to the negative 11 times negative 2. So let's write 2 times negative 2, and then x raised to the 11 times negative 2 is positive 22. Then y raised to the raised to the negative 11 times negative 2 is positive 22. And then z to the 11 times negative 2 is negative 22. So let's put this all over 1 and then simplify this. So we have a negative exponent for this thing, so it's going to move to the other side. And also z to the negative 22nd power, and we're going to move that to the other side. So what remains up top should be the x to the 22nd power times y to the 22nd power all over 2 squared. Again, the negative exponent goes away after you move it, times z to the 22nd power. Now, we're not done yet because look, that 2 squared can be rewritten as 4. So x to the 22nd power times y to the 22nd power is all over 4 times z to the 22nd power. Okay, and that's your answer. For number 20, we have the quotient, power of a quotient. So what I can do is we're going to focus the stuff up top, right? So we're going to distribute the negative 1 to each of those things. So we have x raised to the negative 5 times negative 1. So basically what we did with 19 and 18. So x raised to the negative 5 times negative 1. And then we have y raised to the negative 1. All over y raised to the third power times negative 1. So you have whatever you do up top, you have to do down below when it comes to a power of a quotient. You're basically distributing the negative 1 to the numerator as well as the denominator. Okay, so now we have x raised to the positive 5. So x to the 5th power times y to the 1st over y to the negative 3rd power. Notice that we have a negative exponent down below. So we need to take this and move it up top. Okay, so we have x to the 5th power times y to the 1st times y to the 3rd power. Now, you're not done because if you're multiplying the same base, you have to add the exponents. So notice that we have a y and a y, so x to the 5th power. And what you're going to do is you're going to write y. Okay, so let me go ahead and just erase this, and then there you go. So we have y, and then we're going to add these exponents, so 1 plus 3. So your answer is x to the 5th times y to the 4th. Okay. Number 21, same idea, except we have a negative 2. So we're raising all of these things to the negative 2nd power. So for the top part, we have x raised to the negative 3 times negative 2. Then y raised to the negative 2nd power over y to the fourth times negative 2. Okay, so first part, x to the 6th times y to the negative second power over y to the negative 8th power. Okay, so what we're going to do is we're going to move the negative exponents to the other side. Or in this case, if I'm looking at y raised to the negative second power, of course we're going to take that and move it to the other side. And this y to the negative 8 power, we're going to move it to the other side, okay? So x to the 6th times y to the 8th over y to the 2nd. Now, if we look at this rule, if you're dividing the same base, you're subtracting the exponent. So notice that we have a y base up top and a y base down below. So I need to subtract these exponents. So we have x to the 6th times y to the 8th minus 2. And this is your answer. Okay. Number 22, we have 525 raised to the 0th power. And of course, explained in the beginning, any non-zero number with an exponent of 0 is equal to 1. So this 525 raised to the 0th power, yes, 525 is a large number, but it's raised to the 0th power. So your answer is just 1. So for number 23, we have this product being raised to the 0th power. So we can treat this whole product as one number, right? It doesn't matter what number you choose, but it's being raised to the 0th power. So the answer is 1.
So, laws of exponents here, simplifying. First thing here, we've got 5 squared times 5 to the 6th. So to simplify this, the bases are both 5, so they're the same. They're being multiplied, so that means we need to add our exponents. So 5 to the 2 plus 6 is 5 to the 8th, which is a big old number, okay? 7y to the 5th times 6y. So in this case, remember, this is all being multiplied together. So we have 7 times 6 times y to the 5th times y to the 1st. So 7 times 6 is 42. Y to the 5th times y to the 1st. Same bases being multiplied, so we add, and we get 42y to the 6th. Okay? Number 3, same thing. All this stuff's being multiplied together. So we're going to go negative 3 times 5 times x squared times x to the 1st. Oops. Times y to the 7th times y to the 6th. So negative 3 times 5 is negative 15. And then we're going to add those exponents because everything's being multiplied together. So negative 15x to the 3rd, y to the, that's 7 plus 6 is 13. Okay? So we got those. Now, number 4, y to the 6th divided by y. So we have the same bases being divided this time. So remember that denominator, that y in the denominator is y to the 1st power. So when we divide the same base, we subtract exponents. So y to the 6 minus 1 would be y to the 5th. Okay. More division here. 6 to the 13th divided by 6 squared. Again, both of these are the same base. They're base 6. So that just means we're going to take 6 and then we're dividing, so we're going to subtract those exponents. 6 to the 11th. Okay, we got that. Now, 6, 10a to the 7th, b to the 9th, divided by 15a to the 5th, b to the 4th. So with these coefficients out front, we're going to divide those, right? And then we have a to the 7th, a to the 5th. So we're going to go a to the 7 minus 5, right? Because those a's are being divided. And then same thing here, the b's are being divided. So we're going to subtract those exponents. And then with this 10 over 15, we can divide a 5 out of both of those and make it 2/3. And then that would be a squared b to the 5th. Right? You can leave it like that, or if you were to multiply all this out, you could just make it 2a squared b to the 5th all over 3. Okay, both of those are acceptable answers, all right? Number 7, we have 3x squared to the 0 power. So everything in there is being raised to the 0 power, and anything to the 0 power is 1. So that whole thing is just 1. Okay? Same thing with 8. Negative 3x plus 7 to the 0 power. So all of that is being raised to the 0. So this is just 1. Now, when we get into number 9, 8x to the 0 plus 5. So in this case, the only thing being raised to the 0 power is the x. So x to the 0 is 1. So 8 times 1 is 8 plus 5 is 13. So you got to be careful about what's actually being raised to the 0 power, all right? Number 10, 2 to the negative 3rd. So we got a negative exponent. So right now, remember with negative exponents, we need to think about fractions in terms of fractions. So 2 to the negative 3rd, to make that exponent positive, we need to take this thing and shift it to the denominator. So that would become positive 2 to the 3rd in the bottom. And since we took all the stuff out of the top, we need a placeholder. So we put a 1 up there. And then this would just be 2 to the 3rd is 8. So 1 over 8. Okay? Number 11, 4x to the negative 4. So again, we got to be careful about what's actually being raised to the negative 4th power. So this is really 4 to the 1st times x to the negative 4. So the only thing being raised to the negative 4th power is the x. So that's the only thing that's going to be moved. So that 4 is going to stay in the numerator, and then it would turn to x to the positive 4th in the denominator. Okay? And then same thing with 12. Be careful about what's actually being raised to that negative exponent. So in this case, right, we're going to take this x to the negative 2nd, and to make it positive, we're going to shift it down to the bottom. And this y to the negative 3rd in the bottom, to make it positive, we're going to shift it to the top. So we'd have 3 on top, and then y to the 3rd, and then 5 on bottom, x squared. That's what we got, okay? And then for 13, we have x squared to the 8th power. So we have a power to a power. So that means we're going to multiply those powers. So x to the 2 times 8 would be x to the 16th. Okay? Y to the negative 3rd to the 4th. So again, power to a power. So we're going to take negative 3 times 4 and get negative 12. And we're not done simplifying until all of our exponents are positive. So again, think about it's in a numerator. So to make that positive, we shift it to the denominator. And then there's nothing left in the numerator, so we have that 1 as a placeholder, right? And then for 15, we have 4x cubed yz all to the 3rd power. So we have a bunch of stuff in parentheses being cubed. So to simplify that, we take everything in those parentheses and we cube it. So everything in there gets taken to the 3rd power. Okay, so then we simplify. 4 to the 3rd is 64 times x cubed cubed. So power to a power, we multiply those. So 3 times 3, and then 1 times 3, and then 1 times 3. So we have 64. That would be x to the 9th, y to the 3rd, z to the third, right? And then same thing goes with fractions. If you have a fraction raised to a power, just like this, everything in this set of parentheses needs to be, in this case, squared. Right? So all of this stuff in here needs to be squared. So 2 squared is 4. A to the 5th squared, right? Power to a power. So multiply. And then b to the 7th squared in the denominator, so we multiply. So 4a to the 10th over b to the 14th is what we end up with that, all right? So again, these are all laws of exponents you talk about in Algebra 1.